Alright, so our objectives in Lesson 310 are to solve an application problem involving a system of equations. Illustrate the solution to an system of equations using a table and, of course, also a graph. We are going to do a little bit of Desmos work here. Desmos really is useful for solving systems of equations. And when graphing calculators first came out, before then, if your answer wasn't an integer, well, you had to make your best guess. You'd have to solve things algebraically if you wanted an exact answer. But with the invention of graphing calculators and, especially, Desmos, it's so simple to go ahead and graph these and find the solution as well. All right, so let's go up here. It says right here. When we're studying a situation with two variable quantities, we'll use x and y. We might be able to set up a system of equations. This is two or more related equations that share common variables. Let's start off with a situation that might lead to a system of equations. So here we go. The shipping manager at a small business sent out a shipment of 3 coffee mugs, so 3 coffee mugs and 6 promotional packets on Monday, and the total shipping weight was 42 ounces. I'm just going to write stuff down as we see it. On Wednesday, she sent 6 more mugs, so I use M for mugs, that makes sense. And 3 more packets. This time the total weight was 48 ounces. Now the boss wants to know the shipping weight for each packet. So that's what we don't know, the weight for each packet and for each mug. Our goal is to help the shipping manager out. So we're going to need this information on the next page. In this problem, there are 2 variable quantities. Remember, vary means able to vary, that we don't know. The shipping weight of the packet and the shipping weight of the mug. And they want us to let X represent the weight of the mug. And they want us to let Y represent the weight of one packet. And they want us to write an expression that describes the combined weights of 3 mugs. Okay, I have 3 mugs and they weigh X ounces each. And so plus 6 packets. I have 6 packets and they weigh Y ounces each. So that's what they were looking for. And then on 3 it says use your equation from question, your expression from question 2 to write an equation that describes the weight of the first shipment. They told us that first shipment weighed 42 ounces. So my 3 mugs and my 6 packets would be 42 ounces. Well, look what we see here. There's our equation. If we repeat what you did in question 3 for the second shipment, we get our first look at a system of equations. Solve each equation for y. Now, the reason why we're doing that right now is they're going to want us to put this in a table, and they're wanting us to graph this as well. So just bear with me. 3x plus 6y equals 42. So let's subtract 3x from both sides, and that gives me 6y equals negative 3x plus 42. Now let's divide every single term by 6, and you see we get y equals negative 1/2 x plus 7. All right, go ahead and pause this and see how well you do solving the next one for y. Okay, so what I did is I subtracted our 6x from both sides first. So I got 3y equals negative 6x plus 48. And then I divided every term by that 3. So I end up with y equals negative 2x plus 16. So for number 5, they want us to make a table of values for each equation. So you're going to substitute 2 in for x, get your y, and so on. And go ahead and pause and see if we come up with the same thing. Okay, so they really want us to think about this later. I want to think about it now. Do you notice how when x is 6, the outputs are the same? So it looks like we have found our solution to the equations. It looks like when x is 6 and y is 4, okay, both of those equations are, that's a solution to both equations, I guess is what I'm trying to say. All right, now let's graph and see if we don't have the same thing going on. Okay, so with our first equation, we had points 2, 6. We had 4, 5. We had 6, 4. And we had 8, 3. And we had 10, 2. And I would pretty much say that we could go ahead and plot 0, 7 because that's clearly the y-intercept there. All right, for the next one, we could tell that our y-intercept is 0, 16, but that's kind of off the graph. So we have 2, 12, but that's off the graph. And then we have 4, 8. Okay, and then 6, 4, and then 8, 0. That's close enough for government work there. Oops, I missed. Sorry about that. Pretend that that was a beautiful line. Okay, so hopefully you are seeing that these lines intersect at the point 6, 4. Okay, that makes that a solution to this particular system of equations. So let's go ahead and answer that, 6, 4. And then it says plug the coordinates of the point back into the original equations. What do you notice? So let's go ahead and write our original equations. Oops, that's a y. So 3 times 6 plus 6 times 4, is that equal to 42? Yes. And then 6 times 6 plus 3 times 4, is that equal to 48? Yes. So both equations are true. Congratulations, you just solved a system of equations. The point 6, 4 provides a value for each variable, x equals 6 and y equals 4, that makes both equations true, and that's what the solution is. A solution to a system of two equations is a pair of numbers, one for each variable, that make both equations true when substituted in. Solving a system means finding all pairs of numbers that are a solution. So what does the solution we found tell us about the shipping weights? We know that each mug, is 6 ounces shipped. Each packet, if I can write today, is 4 ounces shipped.